understand the basic concepts of motion under gravity, and that too when the body is moving in one dimension only. That is, the body is moving purely along one dimension and it is moving purely under the influence of gravity. So over here we shall be dealing with the cases like from the surface of earth our body is projected up with the velocity of 20 meter per second, and we are interested how much time will it take to reach the topmost position and how much total time it will take for the whole journey, that is coming back to the original position from which it has been thrown up, or what is the time it takes if a body has been thrown up vertically up from the edge of a tower, it goes up, comes down, what is the total time it is going to take. Questions like this, they are studied on the topic motion under gravity and motion in one dimension. In all these cases we have to understand that the body is moving, once it has been thrown, it is moving purely under the influence of gravity. Whenever a body is thrown like this or this, irrespective of what is the velocity which is given, unless until it is too large, like escape velocity for earth is 11.2 km per second, or when it goes beyond the gravitational pull of earth, we are not talking about those cases. We are just talking about the cases when the velocity is very small as compared to that escape velocity. When the velocity they are very small, then this body is purely moving under the influence of gravity, and in all those cases the acceleration which is introduced in the body is 9.81 meter per second square because of gravitational pull of earth. Many times students they get confused, that is the direction of velocity and direction of acceleration they have to be same. No, it is not necessary. Velocity and acceleration, they are the two different physical quantities. Acceleration is rate of change of velocity. The direction of acceleration, it may or may not be same. When the body is thrown in the gravitational field of earth, then earth is pulling all the objects toward its center with a force equal to weight of the body m into g, and going by Newton's second law of motion, net force is equal to mass into acceleration. So following this law, the net force onto the body is mg in the direct downwards. That is, if this is earth, big earth, and over here a body is projected up, then earth has a tendency to pull this object always towards the center with the force equal to mg. Earth is applying a force onto this body of mass m, that is m into g, that is weight of the body, and by going by Newton's second law, that is net force equal to mass into acceleration, and the direction of net force and net acceleration they have to be same. So that's why mg is equal to ma and acceleration is going to be g directed downwards toward the earth if we're talking about the acceleration vector. So acceleration of all the bodies which are being thrown in the atmosphere of earth and they are purely moving under the influence of gravity, they are going to have a net acceleration toward the center of earth equal to g, that is 9.81 meter per second square. It is irrespective of what is the velocity you have given. If you give higher velocity, this will go to a higher height, but otherwise, be it this case when the velocity given is lesser, this still the acceleration is going to be 9.81 meter per second square directed downward. If you give it a bigger velocity, it will reach higher, that is fine, but the acceleration due to gravity will still remain same. Please do not confuse between the direction of velocity and direction of acceleration. Let us understand motion under gravity by taking some simple examples like this. We take a simple case where from the surface of earth our body has been projected up with a velocity of 30 meter per second. It rectilinearly goes up, comes down. It has been projected up from the position A and it comes back, it goes up and comes back to the position A only. Let's call it as A dash to differentiate between these 2 points which are obviously coinciding with each other. To do questions like this, we break this journey into 2 parts. One is its journey from A to the topmost position, that is A to B, and then second is we shall be doing B to A dash. One is upward journey, the second is downward journey. When we are considering the motion from A point to B point, we are not much bothered what is happening to the body before this point of observation and after this point of observation. Our focus is primarily for the journey part from A to B. And for to solve this, what is the time it is going to take, that is time from here to here, that is called time of ascent. And B to A dash will be called time of descent. So if we have to find what is the time of ascent, we shall be using our equations of kinematics, and we can use what it seems appropriate is V is equal to U plus AT. where V stands for final velocity, U stands for initial velocity, A for the acceleration and T for the time for journey from A to B. What is V final velocity? Final velocity at the final point, that is B point. This is initial point, this is final point. Velocity at the initial point will be called initial velocity. Velocity at the final point will be called final velocity. So V stands for final velocity. When we say this is the highest point, so obviously over here at the highest point, the velocity of the body is going to be equal to 0 only. So this is 0 is equal to U. U is at A only, it is 30 meter per second, it has been given to this. So 30 plus A. Now acceleration. When the body is going up, we know that is over here the velocity is 30 meter per second. It gradually reduces and over here it comes to be 0. And how it reduces, who decides that? Earth decide that. Earth says, I am going to introduce an retardation or acceleration of 9.81 meter per second square in the downward direction, or the body starts retarding in this direction with a value of 9.81 meter per second square. For a time being, only for the ease of calculations, let's take the value of G. Instead of 9.81 meter per second square, let's take it as 10 meter per second square, so that our emphasis is more on understanding the concepts rather than getting involved too much into the calculations. So when the body is going from here to here, the velocity is reducing. When the velocity is reducing, it is retarding. Retarding means negative acceleration. And what is that? Who decides that? Earth decides that. So over here A comes out to be minus G, that is minus 10 into T. So T comes out to be 3 seconds. Then we have to find the time of descent, that is time of descent. What is time of descent? Time of descent is, that is time from B to A dash. We may come across that is time of ascent is equal to time of descent. Time of ascent is equal to time of descent only when we neglect air resistance, etc. If we take into consideration the air resistance, then the time of ascent will not be equal to time of descent. Anyway, we are taking the ideal conditions where the air resistance is negligible. Time of ascent will be equal to time of descent, but still we cannot presume it. What we can presume is that whatsoever the distance it goes up, the same distance it will come down. It's a simple basic logic. So first let's find out what is the distance it travels from A to B. For that, what we can do is we can use the equation V square minus U square is equal to 2AS. And when you use it, V square minus U square is 2AS, that is once again our journey is from A to B. V stands for final velocity at the B point. At the B point it is 0 minus U square. Initial velocity where at A point the velocity is 30 meter per second. So it is 30 square. 2 A is acceleration due to gravity. When it is going up, it is reducing, the velocity is reducing. So as a result, it is going to be taken as minus 10. Instead of taking G as 9.81 meter per second square, we are taking it as G is equal to 10 meter per second square. So into S, so it is 30 into 30 minus will go off. 30 into 30 over 2 into 10. This goes off. That is 45 meter. So this body will go 45 meter before it comes to momentarily to a stop. When we have to find the time from B to A dash, obviously this will go down once again by 45 meter only. So once again we use S is equal to UT plus half AT square. Now what is the distance it travels from B to A dash? It travels the same distance, that is the same distance it has gone up. So it is 45 meter. Now thing to understand is U is initial velocity is not the velocity over here, but now our journey is from B to A dash. From B to A dash, that is original point. What is the velocity at B? Velocity of momentarily velocity at B is equal to 0. So that's why whatsoever the final velocity for A to B, it becomes initial velocity for the journey B to A dash. So initial velocity at B is 0 plus half. Now the point to note is when it is coming down over here, the velocity is 0. As it comes down, the velocity is increasing, means acceleration is positive because velocity is increasing. When the velocity is increasing, take acceleration as positive. When the velocity is reducing, take acceleration as negative. And it has been thrown in the field of gravity. So the value of acceleration is going to be 9.81 or 10 meter per second square. When it is going up, it is reducing, so it is going to be taken as minus 10 meter per second square. When it is coming down, it is increasing, velocity is increasing, so that's why we take acceleration as plus 10 meter per second square. So it is plus 10 into t square. This comes out to be 90 divided by 10 is equal to t square. So t comes out to be 3 seconds only. So we see that is time of ascent and time of descent, they come out to be same. So over here what we have done is we have taken the acceleration as positive when the velocities they are increasing, and we have taken the acceleration as negative when the velocity or speed that is reducing. So over here what we have done is, as far as the acceleration is concerned, when the body was going up, we have taken the acceleration as negative, and when the body is coming down, we have taken the acceleration as positive because the velocity is increasing. Now in doing the questions like this, motion to gravity, we have two ways to solve such questions. So one is to take acceleration as positive when the velocity is increasing, and take acceleration as negative when the velocity is reducing. All the while you can use the equation of kinematics, these equations of kinematics like V is equal to U plus AT, V square minus U square is equal to 2AS, S is equal to UT plus half AT square, etc. You can use these equations only when the value of acceleration is constant. This is uniformly accelerated motion. The value of acceleration during this whole journey, it should not change. If it is 3 meter per second square for some journey and you wish to apply equation of kinematics, then throughout the journey this acceleration should remain as 3 meter per second square. When the acceleration changes, there is a jerk in the motion. The other way of solving such questions is using the sign convention. Sign convention at times makes our job much easier. It says if in one direction we are taking the vectors as positive, in the opposite direction we have to take the vectors as negative. That is, if we are taking the vectors in the upward direction as positive, then in the downward direction we have to take it as negative. If this way we are taking it as positive, this way we have to take it negative. If this way we are taking it as negative, this way we have to take it positive. So they are opposite vectors only. So how to use that concept in questions like this? So in questions like this, if we don't use this, what we have to do is, first is we have to find the time of ascent. We find the time of ascent. Then we find what is the total distance it will travel from here to here. And then we say that is whatsoever distance it travels up, the same distance it will travel down. And then once again we use the equation of kinematics to find the time of descent. Then we add the two. But if we use this sign convention, it makes our job much easier. Like, instead of going from, first is from A to B and then from B to A dash, let's directly go from A to A dash. We consider this. So this is our initial point of observation, this is the final point of observation. And over here, we apply the equation S is equal to UT plus half AT square. And we put the lines over this, that is, this is vector, this is not distance now, it is displacement, this is initial velocity, we have to take the direction also into consideration, same thing goes for acceleration also. We are going from A to A dash, A and A dash they coincide, so the net displacement for A to A dash is going to be equal to 0 only. Initial velocity, we are at point A. We have given a 30 meter per second in the upward direction. In the upward direction, let's take the vectors as positive, so this is going to be 30. Positive plus 30 into t plus half acceleration due to gravity. We know all the time acceleration due to gravity is the downward direction. Why? Because when the body has been thrown up, there is only one force which is acting on the body, it is mg in the downward direction. Newton's second law says that is net force is equal to mass into acceleration, and the direction of net force and net acceleration is always going to be same. The net force onto this body, whether the body is going up or coming down, the net force which is acting on the body is in the downward direction only. So mg is equal to, that is the net force is equal to mass into acceleration, m and m that goes off. So acceleration is g, and obviously it is in the downward direction. In the downward direction we are taking the vectors as negative. So whether the body is going up or whether the body is coming down, it is accelerating in the downward direction. Also, if we understand in the layman's language, when the body is going up, its velocity is reducing in the upward direction. Acceleration is opposite to that. If the velocity is reducing in this direction, obviously the velocity is increasing in this direction. The direction of acceleration is the direction in which the velocity is increasing. If the velocity is decreasing in this direction, obviously the velocity is increasing in this direction. So it means when the body is going in the upward direction, its velocity is reducing in this direction, but the velocity is increasing in this direction. So the acceleration is directed downward when the body is going from A to B. And when the body is going from B to A dash, that is in the downward journey, obviously the velocity is increasing in the downward direction. And the direction of acceleration is in which direction the velocity is increasing. In the downward part of journey, the velocity is increasing the downward direction, so acceleration has to be in the downward direction and its value has to be 10 meter per second square. So whether the body is going up or whether the body is coming down, the acceleration is g in the downward direction. And we are taking the vectors in the downward direction as negative. This acceleration vector is directed downwards, so that's why it has to be taken as minus 10 into t square. So if we solve it, so this comes out to minus 30t is equal to minus half 10t square. Minus minus goes off, t and square, because t is not equal to 0, we can cancel it. So that comes out to be 30 is equal to half 10t. So t comes out to be 6 seconds. That is, this comes out to total time of flight. That is the total time it is going to take to go up and come down. This comes out to 6 seconds only. That is the same time. We had found the time of ascent as 3 seconds and we had found the time of descent as 3 seconds going by the previous method. So the total time was 6 seconds, and over here also just in one equation we get the total time of flight as 6 seconds only. So this way you can solve the questions on motion and gravity, and over here you have two ways to solve it. One is without sign convention, the second is with sign convention. When you are solving the questions without sign convention, over there what you do is take acceleration as positive when the velocity is increasing and take acceleration as negative when the velocity is reducing. So this is one part, that is when you are going to solve the questions without sign convention. And if you intend to use the sign convention, over there you take the vectors in one direction as positive and in the other direction, opposite direction, as negative, and then over there you use equations of kinematics taking care of their direction also. And in all these cases the action due to gravity is directed downwards, and if you are following this sign convention, you can follow the other sign convention also, but generally over here we say that is y-axis is positive in the upward direction and y-axis is negative in this direction. So let's follow this sign convention only, and if we follow this sign convention, then the action due to gravity, because it is in the directed downward direction, it is taken as negative. Now let's say from the edge of a tower, this is over here, this is a tower, and let's say its height is 50 meter. From the edge of a tower, a body is projected with a velocity of 20 meter per second. It goes up, comes down and strikes the ground. So this is point of projection A, this is the topmost point B, and this is the point on the ground where it is going to strike the ground. We are interested in finding what is the total time of flight. That is, total time of flight from A to C is equal to time from A to B plus time from B to C. So this is the total time. One is we can solve this question without using sign convention. That means we are going to take acceleration as positive when the velocity is increasing, and we are going to take acceleration as negative when the velocities they are reducing. Obviously when it is going up, the velocities they are reducing, so that's why acceleration is going to be taken as negative, and when it is coming down, then certainly the velocity that is increasing, we are going to take acceleration as positive. So let's find time from A to B. To find time from A to B, that is, this is our initial point of observation, this is final point of observation, initial and final point of observation. So we use V is equal to U plus AT. V, final velocity over here at B point, is going to be equal to 0. U, initial velocity at A, it is 20 meter per second, plus acceleration, that is acceleration due to gravity. Now it is reducing, this way velocity is reducing. Don't say acceleration is reducing. Acceleration is 9.81 meter or 10 meter per second square only. That is not changing. This is uniform. What is changing is velocity is changing. Velocity is reducing. So acceleration is, because the velocity is reducing, so it is minus 10 into t. So t comes out to be 2 seconds. So this is the time it is going to take. And now if we have to find what is the time it is going to take from here to here, we will need, that is, how much distance it travels from here to here. But because otherwise we cannot use the equation, any other equation, that will be of no use. So if we have to find the distance from A to B, we say V square minus U square is equal to 2AS. V, once again, A to B, final velocity at B is equal to 0 only. 0 square minus U square. 2, acceleration is minus 10 into S, so S comes out to be 20 meter. So this height from here to here is going to be 20 meter only before it starts its downward journey. And now if you have to find what is the time from B to C, that is B to C, we can use S is equal to UT plus half AT square. What is the total distance from B to C? It is 50 plus 20. This is the total distance B to C. So it is 50 plus 20, 70 is equal to u, initial velocity. Initial velocity where? At the point B, because now this is our initial point of observation and this is final point of observation. So at B, velocity is 0, 0 plus half A. While coming down, the velocity is increasing. Velocity is increasing means acceleration is positive. So 10 into t square, this 7 into 2, 14. So this is 14 is equal to t. So this is t is equal to root 14. So t is 3.74 approximately. So the total time will come out to 3.74 plus 2, that is this time plus this time. So 2 plus 3.74. So total time of journey is 5.74 seconds. Now let's use sign convention. We use now sign convention and we see whether our answer comes out to be same or not. In sign convention, we take the vectors in the upward direction as positive, in the downward direction as negative. So if we use sign convention, we can directly go from initial to final position, that is A to C. This is our initial point of observation, this is final point of observation. One thing to understand is, during this whole journey, the value of acceleration is 9.81 or 10 meter per second square and it is directly downward. So acceleration is constant throughout this journey and we can easily, comfortably, we can apply equation of kinematics. So over here, when we go from A to C, let's say we say S is equal to ut plus half at square. We apply this equation. S is equal to ut plus half at square. So now S is not distance, but this is displacement. What is the displacement? Displacement is join the initial point and the final point with the arrow on its head to the final point. From initial to final towards the final point. What is that? This length is 50 meter. And is it in the downward direction or upward direction? This is in the downward direction. Downward direction, it has to be taken as negative. So it is going to be minus 50 u, initial velocity, where? At the point A. What is the value? It is 20 meter per second. In the upward or downward direction? In the upward direction is positive. So it is plus 20 t plus half. A is acceleration due to gravity. In which direction? It is directly downwards. Directly downwards means negative. So it is minus 10 into t square. So this is the equation, this is the quadratic equation we get, and we can solve this. So we can solve this quadratic equation, and this comes out with t square minus 4t minus 10 is equal to 0, and t is equal to, we know, if the standard form of quadratic equation is ax square plus bx plus c is equal to 0, then the roots, they can be found as x is equal to minus b, that is coefficient of x, plus minus b square minus 4, a is coefficient of x square, c is constant over here upon 2a. When you put the values, once again the total time of flight comes out to 5.74 second, and this is the same time what we have found when we had not used the sign convention. So you solve it this way or using sign convention method. Both ways the answer is going to be same. You have to see that is which method you wish to use. Now let's say you have to find the velocity of the same body which is projected like this after let's say 3 seconds. What is the velocity of this after 3 seconds? Suppose this we have to find out. Now we don't know after 3 seconds whether this body will be going up or coming down if we don't use sign convention. Then certainly first is we will to find out how much time it takes to reach the top. Suppose it takes time, suppose 2 seconds to reach the top, then certainly after 3 seconds it will be coming down. Suppose it takes 4 seconds for its journey from A to B, it means at t is equal to 3 seconds it will still be going up. So if we use this method, we are not very sure whether the body will be going up or coming down. So to find the velocity at any time interval, first we have to find out how much time will it take in going from here to here, then only we can say this body will be going up or coming down. But sign convention, that way becomes very handy. It says I am not bothered whether the body is going up or coming down, I'll take care of it by myself. That is, it says you start your observation at A only. This is our initial point of observation. It says apply V is equal to U plus AT. It directly says apply V is equal to U plus AT, and I'll tell you whether the body is going up or coming down. It says V is equal to U plus AT, so V is equal to U is over here, that is plus 20. Acceleration due to gravity, it is in the downward direction, downward direction is negative, minus 10 into t, we are taking t as 3 seconds. So this is 20 minus 30, that is minus 10 meter per second. Minus 10 meter per second, this is the velocity vector it has come. So it has got both the things, it has got magnitude also, it has got direction also. Velocity of minus 10 meter per second, it says, that is the magnitude is 10 meter per second, and now the body shall be moving in the negative means downward direction. So the body will be coming in the downward direction at t is equal to 3 seconds, and its speed or velocity is going to be 10 meter per second in the downward direction.